Alright, here's our lesson on solving linear systems by substitution. In the lesson that you did earlier today, you solved the linear systems by graphing, and we noticed that the solution of the system was where the two lines intersected. It was the x and y coordinate. That's going to be true for all linear systems. However, we don't always want to have to graph them because sometimes that takes us a while. So now we're going to solve the systems of linear equations by substitution. And we always do these problems so that eventually we can solve them using a real-world situation. So the key concept here, the first step that you want to use is solving one of your equations for one of its variables. When it's possible, solve for the variable that has a coefficient of 1 or negative 1. So if you see that you have an x or a y, just solve for that rather than finding a 2x or a 3y. So it just makes it a lot easier when we're doing this process. The second step is that you substitute the expression from step 1, substitute that into the other equation, the one that you haven't used before, and then solve for that other variable. And then lastly, once you have that other variable solved, you're going to substitute that answer from step 2 back into the revised equation. And when I show you how to do this, I'm going to use circles and arrows and everything so that you can see how I think it's easiest for it to be done. So here we go. It would probably be helpful if you have some paper so that you can write this down. So first we're going to solve the linear system y equals 3x plus 2 and x plus 2y equals 11. Remember, we could graph these. However, if we graph this bottom one, we're going to have to put it in slope-intercept form, and it looks like my y-intercept is going to be a fraction, which is not terrible, but I'd rather not have to deal with that. So step 1 said let's look and see if we can get a variable basically that's isolated. And in this case, my first equation is solved for the y. So what I do is I circle that one because I know I'm going to use it. So step 1 is done. Step 2, I'm going to take this equation and I'm going to substitute it into the other equation for, in this case, the y variable. So I'm going to go x plus 2 and then parentheses, instead of the y, I'm going to substitute 3x plus 2 because that was the y that we had up here, and then equals 11. Now, still following along with step 2, I'm going to solve this equation for the x. I've eliminated the y variable, so now I can solve this for the x. Well, you know, if we have distribution, we have to do it. So I'll go x plus 6x plus 4 equals 11. Combine our like terms, so we end up with 7x plus 4 equals 11. We would then subtract the 4 from both sides, so 7x equals 7. Divide by 7 and x equals 1. So far in our coordinate we have 1 comma, and I have to figure out the y. And then the last step, we take this new value that we found and we put it into, they call it the revised equation. Well, I haven't really revised it up here, but I will in another problem. So I'm going to put this one back up here. That's why I circle them, because I put the circles together. So I end up with y equals 3 times 1 for the x plus 2. So y equals 3 plus 2, which is 5. So my solution is 1, 5. If I were to graph these two lines would intersect at the point 1, 5. Now let's see what happens if step 1 isn't already done for us. So here we have x minus 2y equals negative 6x and 4x plus 6y equals 4. Remember, on step 1 it said it's easiest if you can try to find a variable with a coefficient of 1. And I find that right here. So I'm going to take the equation x minus 2y equals negative 6, and I'm going to solve this one for x, for no other reason than I think it's going to be the easiest one to solve for. So if I solve for this for x, all I have to do is add the 2y to both sides. So I get x equals 2y minus 6. And this is the one I revised, so that's the one I'm going to circle. Step 2, I put this up into the other equation, the one that I haven't revised. So I have 4 times the quantity, 2y minus 6, plus 6y equals 4. Same drill that we had back here. I'm going to solve it. I have the distributive property. So I end up with 8y minus 24 plus 6y equals 4. Combine my like terms, that gives me a 14y minus 24 equals 4. I'll then add the 24 to both sides to get 14y equals 28 and divide by 14 so y equals 2. And I circled that one. So far my solution is x comma 2. Now I will take this y and put it into the revised equation, and x equals 2 times 2 minus 6. So x equals 4 minus 6, which equals negative 2. So my solution is the coordinate negative 2, 2. Of course, you know we're going to have real-life problems, so here we have a multi-step problem. Many businesses pay website hosting companies to store and maintain the computer files that make up their websites. Internet service providers also offer website hosting. The cost for website hosting offered by a website hosting company and an internet service provider are shown in the table. Find the number of months after which the total cost for website hosting will be the same for both companies. So here we have the setup fee is $10 and then the cost per month is $21.95. Here there's no setup fee, but the cost per month is $22.45. So we need to come up with our two equations. So this equation, it's a $10 setup fee,